Hello guys, I am Satyam and you are here on our one and all channel Satyam Ideal Learning, and today we will be discussing about matter only, different states of matter which are solid, liquid and gas. These three states of matter today we will be discussing. Guys, there are two more states of matter which are plasma and Bose-Einstein condensate. This is for knowledge only, general knowledge. So there are mainly five. Okay, five states of matter are there. Three are common, solid, liquid and gas. And the two which are extra, which is for the only general knowledge, which is plasma and Bose-Einstein condensate. Okay. Now, today we will be discussing about these three states of matter. Now, solid. Solid has definite shape and definite volume. At the very first, I want to tell you that see, matter is made up of very small particles and we cannot see them. Okay, the particles are not visible by our naked eyes. Okay, by our unaided eyes, we cannot see them. We cannot see the particles. And you already know that the matter is made up of small particles which are known as molecule. You already know. And element is made up of small particles which are known as atom. Okay, so you already know these things. Now, see, there are two things which are intermolecular force of attraction and intermolecular space. If there are two molecules, okay, if there are two molecules, the space in between of them is known as interparticle space, and the force with which they are attracting each other, there are two molecules and they are attracting each other with a space, with a force, that is known as intermolecular force of attraction. Interparticle force of attraction and intermolecular force of attraction. Okay, so there are two, intermolecular force and intermolecular space. Intermolecular space is in between the two molecules. Okay, and the intermolecular force is that force which is being attracted by these two molecules. So these two molecules are attracting each other with a force which is known as intermolecular force of attraction. Clear this thing? Now see, molecules are always in random motion. They are always in motion. In solids, there is a very compactness. There is very compactness. That is why they are not in motion. They are in vibration. So they vibrate. In solids also, they vibrate. Okay. And in liquid and gas, they are in motion. Continuous motion. Now today we will be discussing in detail. So in solid has definite shape as well as definite volume. Now how it has definite shape and definite volume? See, the intermolecular force of attraction between the particles of solid is very strong. It is very strong. In between the particles of solid, the intermolecular force of attraction is very much strong. That is why they are tightly packed, and the intermolecular space is almost negligible. It is very small. Interparticle space is very small. Okay. So if the force of attraction is very strong, that is why they are held tightly. They are packed tightly. Okay. So solid have definite shape. That is why they have a definite shape. Because of the strong intermolecular force of attraction. They have a definite shape as well as they have a definite volume also. Clear? Now, position in molecules in it are fixed. See, because of the intermolecular force of attraction, the position is fixed. Okay, they only vibrate. Clear? So when they only vibrate, and the position in the molecules in it are always fixed. Now see, they cannot flow. They can only be heap. Heap in the sense the ikattha hona. Okay, so they can only be heap. They do not flow. They cannot flow. Clear? they cannot flow and they can only be heaped. Now, they have very strong intermolecular force and very small intermolecular space. So, they have a very strong intermolecular force of attraction and they have very small or they have very weak intermolecular space. Clear this thing? Now see. They cannot be compressed. Guys, they cannot be compressed because of the large intermolecular force of attraction and very small, almost negligible intermolecular space. That is why they cannot be compressed. Now see, not need a vessel to contain. They do not need a vessel to contain, guys. Liquid and gases needs a vessel to contain, but this solid do not need a vessel to contain because it has a fixed volume as well as a fixed shape also. Now, has an infinite number of free surface. Now, it has infinite number of free surface. Okay, if there is solid, it has infinite number of free surfaces. It is very common. See, they are rigid as well as strong. If there is more intermolecular force of attraction and very less intermolecular space, then it is very difficult to tear them apart. That is why solids are very rigid as well as they are very strong also. Okay, so solids are very rigid as well as they are strong also. So we have done the part of solid. Now we are coming on liquid. Now see, liquid has no definite shape. They do not have a definite shape but has definite volume. Now I am saying why they do not have a definite shape but has definite volume. See, the intermolecular force of attraction in liquid is less than that of solid. Okay, so the intermolecular force of attraction is less than solid in liquid. Okay, in liquid the intermolecular force of attraction is less than that of the solid, but the intermolecular space is more than that of solid. Are you getting my point? Now see, has no definite shape. Now why it has no definite shape? Because they have less interparticle attraction, interparticle force of attraction. It has less. That is why the particles can interchange their positions. So they do not have a definite shape. Clear? But has definite volume because they can when a container is placed and we flow liquid into it, so it can hold it. That is why they have a definite volume. And when you take a beaker, okay, when you take a beaker and you take a conical flask, you have beaker 50 ml of water, okay, and when you will pour it in the conical flask and then you will measure the quantity of water, okay, then you will get 50 ml only. Clear? So it has definite volume but has no definite shape. And one thing which is very important, that the intermolecular force of attraction, when the intermolecular force of attraction is increased, listen carefully guys, when the intermolecular force of attraction is increased, the intermolecular space is decreased. See, for example, there are two molecules and the intermolecular force of attraction is increased, so they come near and the intermolecular force of attraction increased. You can see that the space is very much very small, so the space is decreased. And when the intermolecular space is increased, the intermolecular force of attraction is decreased. You can see when they are far apart, then the intermolecular force of attraction is decreased. Are you getting my point, guys? This is an example only. Now, see, liquid has no definite shape but has definite volume. Molecules change their positions. I have told you molecules change their positions in liquid state. Now, it flows from higher to lower level. So, liquid flows from higher to lower level because it has less interparticle force of attraction or intermolecular force of attraction. It is less than that of the solid. That is why they interchange their positions. The molecules of the liquid interchange their positions, and that is why they flow from higher to lower level. You also know, you have done, when a water is being split or when a water has been flown from your beaker or your glass to a floor, if it is a slopy floor, then it will go from higher level to the lower level. Now, so it flows from higher level to the lower level. Now, has less intermolecular force than that of solid, I have already told you, but large intermolecular space than that of solid. Clear? I have already told you this thing. Now see, liquid can be slightly compressed. They can be very much slightly compressed. If you take a syringe and the plunger is there in the syringe. Okay, when you pull the plunger and the water is there in your bucket and you are pulling the plunger in the bucket, then what will happen? The liquid will come in, and now you will take a cork and you will press that plunger. That will not go, because liquid can be very slightly compressed. Okay, very slightly compressed. Now see, it will compress, but it will very slightly compress. Okay, needs a vessel to contain. So it needs a vessel to contain. I have already told you. And see, they has only one free surface, because if you take a water and you have pour it in the beaker, then what will happen? There will be only one free surface. If this is a beaker and the water is till this level, so this is the free surface, only this is single free surface. So the water has only one free surface. Now we are coming on gas. See, gas has neither definite shape nor definite volume. So gas do not have neither definite shape nor definite volume, because the intermolecular force of attraction is almost negligible, and the intermolecular space is very much large. Okay, so they have neither definite shape nor definite volume. Molecules of gases can move in all directions. Clear? They can flow also. They can flow also in all direction. They has no gas has no intermolecular force of attraction, but has very large intermolecular space. That is why when you take a naphthalene ball, or you take a perfume, okay, if you take a perfume and then you will spray it at one corner of your room, then what will happen? The fragrance will become spread in all the room. Okay, this is how gases are moving also, and they take the entire space in which they are being produced or released. So has no intermolecular force of attraction, but has very large intermolecular space. So they have very much space. That is why they are increasing their area, no? And that is why they are covering the area. See, gases can be easily compressed. Gases can be easily compressed. The same experiment you have to do. You have to take a syringe and you have to pull the plunger in the air only. Like this way, you have to pull the plunger in air only, and then you will take a cork and then you will push the plunger, and then you will see that that plunger is coming pressed. If you are pushing the plunger, then it is going. Okay, so it can be pressed also. Now see, it needs a vessel to contain. So gas also needs a vessel to contain, and they has no free surface. So they do not have a free surface. I think you have been clear to all this, guys. So bye bye, take care, and we will meet in the next time very soon.